So in this video, we will describe all of the setup screens, all of the buttons, all of the operations of the tester so you're acquainted with the Isaac HD test platform. We've already plugged into wall power in the back, as well as house air supply. Each tester should come with a quick start guide that outlines where to place the air and the maximum supply that can be sent to the machine, as well as any thread sizes or anything special to your machine. Powering up the machine each time does a power on self-test as indicated by the LED, and then the Isaac HD multifunction leak tester about screen flashes for 5 seconds. This gives information such as the serial number, the firmware versions of both the display and the main board. If there's a need for service, this screen will give you the information to use to call and ask for support about your specific machine. Every machine is unique per its application, and so having this serial number will allow any service technician to know exactly about your machine. The unit will always boot up into one of two run mode screens, but first I'd like to go into the parameters screens. To access this mode, we'll press the gear button in the middle of the stack of 3 buttons on the left-hand side. This is where we make all our selections for test setups and extra options that come along with the tester. By default, we go into the pressure screen of the test setup. This is indicated by the pressure button being dark orange compared to all the others at light orange. So you can see we're in the program menu and the pressure submenu of the program menu. The buttons available to us on this screen will be the arrow keys that allow us to increase or decrease the program number. There are 100 stored programs from 00 to 99. The program can also be changed by touching the program number. A keypad will pop up, and we can enter the new program we would like to go to. The program name can be changed simply by touching the name. Another keypad will pop up. We can add whatever we want to, and now that will show up in both the setup mode and the run mode, as well as the data that can be sent out the RS-232 or Ethernet ports. The type is the type of test that is currently selected. This one is a type PD for pressure decay. Each tester will have different test types according to what its application called for. There are multiple test types such as mass flow, vacuum decay, burst testing, and many others. In the center of the screen, we have our test pressure. This will be the goal pressure that we're going to achieve to test our part at. We can simply enter a value by touching it. A keypad pops up, and we can put the new value in. The plus and minus tolerance off to the side are the allowance to reach the test pressure on. A good place to start is the plus and minus tolerance are typically going to be about 10% of our test pressure. If we need to run multiple types of tests, say a pressure decay and then a mass flow test, we can change the program so that after this test has successfully run, we can tell it to go to the next program. So we simply, again, touch the value field, tell it the program we want it to jump to next on a pass, and it goes there. If the test needs to be run multiple times in a row, say you're exercising a part, we can use the loops feature by telling it the number of tests we want to run in a row, anywhere from 1 to 999. So every time the button is pressed, it will run the amount of loops. Leaving it at 0 or 1 is the default. So now that we have our test pressure written into the screen, we need to physically set the regulator in place. We do this by using the feature down lower called Valve On. There's a square check button, as well as a live pressure reading of what the sensor sees right now. To set the regulator, we will cap the test port, either with a product, or in some cases just with our thumb on lower test pressures. If we check the Valve On box, we now get a live reading of the output of the regulator currently. So to meet our test pressure, I'll need to reach behind the tester and turn the regulator handle up until I reach my test pressure. Once I've reached a place where I'm happy with where the test pressure is, and I'm well within my tolerance, I simply can uncheck the box and take my plug or my thumb off the front port, Because we open the test port, it now vents back to 0. But now the regulator is set at the test pressure, ready to go. The next menu is the fixture menu. We have the option, the capability, to add 2 what we call fixture valves or clamp valves. There are 2 basic timers that allow us to turn them on in a staggered mode, run the test, and then turn them off in a staggered mode as well. On the right-hand side, we have a status during test. If you are running a test that requires the part to be tested for an occlusion, we can turn the fixture valves off during the test step. This will allow the part to be drained and checked for an occlusion or blockage. Another nice feature is the hold-on clamps. With the hold clamps on fail, if the tester fails, the fixture valves will stay locked, holding the part in place, and the red LED will begin to flash. This will need to be cleared by an operator stopping what they're doing, pressing the red X button to clear the failure. The fixture valves will then let go and allow the part to be disposed of. No testing will be able to continue until the red LED flashing is gone away. The next menu is the settings, the actual test parameters of the test. Some features on this screen are used by all testers, but not all of the features are used by all the testers. So the fill time, this is the amount of time in seconds allowed to fill the part to the test pressure that was specified on the previous screen. The fill valves then close between the junction of the fill and settle steps. Settle is the amount of time we're going to let the part sit to let the thermodynamics calm down, to let the compliance or stretch of the part calm down prior to the actual test step. In the test step, we are going to watch for a number of decay and call that decay either a pass or a fail. In this particular application, for 3 seconds, we're going to watch for a decay. And then off to the right, you can see the decay value we'll be watching for. In this particular case, a decay greater than 0.0500 psi will indicate that the test is a failure. Any decay less than that and the test will pass. The final timer is the vent timer. This can be seen as a safety. When the part is pressurized, there could be some air that could blow obstructions out at the operator. So for safety, we put a timer in that allows the air to go back inside the machine away from the operator, so when they remove the part, it's safely out of the way. In the test limits, there's one other limit, which is called increase. We have the ability to bracket decays. So the upper limit we call the increase limit. So it must be decay between these 2 values to pass the test. A good feature that we have is called evaluate at end of test. If at any time during this 3 seconds the decay drops below the 0.05 psi in this case, the test will stop no matter how much time is left. But to compare parts like for like, checking the evaluate at end of test will make sure that the test timer runs for 3.0 seconds every time. The pass-fail status will still be carried over. The final feature in the test setup is product volume. By entering a volume here, we will actually calculate what the decay over the test time is in an approximate cc per minute leak rate. We have the unit screen. In the unit screen, we can change the pressure units to any engineering units listed on the screen, as well as the amount of resolution shown on the screen for the test pressure digits. The default is to show 2 digits after the decimal. This can be changed up to 3. And the result digits for the actual decay of the test, the default is to show 4, but we can show anything from no digits behind the decimal to 5 digits behind the decimal. The atmospheric pressure constant is used in the approximate cc per minute leak rate. It is left at standard temperature and pressure conditions of 14.7 of sea level. There are many options that are already built into the tester that allow us to do certain functions. If necessary, the touchscreen can be recalibrated in case you find yourself touching something that doesn't quite line up. The touchscreen will ask for 3 buttons to be pressed so that it understands where everything is. There is a built-in clock with a date and time that at the end of the test, the data will be displayed so that you can track your parts, the date and time that they were tested. An optional I/O can be added to the unit. So in case this is to be run on PLC or an automated setup, we have the I/O setup. Data logging can be, we can send out a string of results at the end of the test out the RS-232 port on the rear of the tester or the Ethernet port on the rear of the tester. Another good feature to have is lock the tester buttons. Once the tests are set up and the tester is calibrated and ready to run, we can lock these features out so the operators can't accidentally change either the program that should be run or any parameters in the tester that should be run. We do this by setting a pin number and then locking the tester with that pin number. We have the serial port settings for the RS-232 and Ethernet settings for the Ethernet setup. The calibrate screen, we offer a warning. The tester is calibrated from the factory, and we provide an NIST traceable certificate of calibration. We recommend the calibration interval be 12 months, but if necessary, the calibration can be accessed via these menus. We pop up a warning screen that says make sure you're not supposed to be here, because manipulation of the calibration will affect the pass-fail status of parts. Going back out to the run mode, we see we have very similar screens as to the setup. We have the ability to change the program. We can see the program number. We can see the new program name that we changed it, as well as the type of test that's going to be ran. The top button in the top stack of buttons takes us to the secondary run mode. This is a data screen only. At the end of the test, we get a numeric result, as well as an alpha pass or fail value. So you can see we passed the test. Here was the decay. If we go back, this screen, which is the blue border around it, is a pressure over time graph. Vertical lines denote step changes. The fill step, then we had a line. The settle step, a vertical line. Now the test step. Now this graph is zoomed into two different sizes. The fill and settle test are based off of the plus and minus tolerance of the test pressure. The test pressure will become the center horizontal of the screen, with the plus tolerance being the top of the screen, the minus tolerance being the bottom of the screen. When we get to the actual test step, we zoom in so that the top of the screen becomes 0 decay. The bottom of the screen becomes what we have set for our decay value. So we can see where we ran this part. According to its failure, we can see it was way far away from being a failure part. In the bottom left-hand corner, we have the timer that will run, as well as the name of the step as the test progresses. At the end, we get a disposition of the test. In this case, it passes. And the decay value of the test. We get the live reading in the bottom of the screen, as well as this is the actual test pressure that was the goal for the test. Each new test will clear itself, but will leave a small trail of where it was so we can see a trending history. As more parts get tested and tested, the screen can clutter up. So the bottom stack button here, where a graph is disappearing constantly, will allow us to clear the screen of any trails that were left over, so we now have a clear picture of what's going on. So now that we're familiar with the screens, for more information, you can go to www.zaxisinc.com, as well as you can email service@zaxisinc.com for support.